Ducati has released its 214 horsepower dieseldromic valve Panigale V4, ending development of ever larger V-twins in favor of a direct connection to all the company has learned in MotoGP. The 1,299 Panigale pushed cylinder bore to an amazing 116 mm, straining the limits of combustion control. In future, engineers say 100 mm will be the largest bore produced, in the form of the Panigale 959. Bore and stroke of the V4 are inspired by the MotoGP limit, 81.0 by 48.5 mm, dimensions chosen to prevent factories from exploring the extremes of Formula One, where at one time bore-stroke ratios closed in on 2.5 to 1, which, in MotoGP cylinder size, would give dimensions of 92.6 by 37.0 mm. Adding 5 mm to the 48.5 mm stroke of MotoGP gives 53.5 mm, which, with the 81 mm bore, delivers a displacement of 1,102.7 cc or 67.3 cc. The power curves shown to me in Bologna revealed peak power at a moderate 13,000 revolutions per minute, at which point the V4's peak piston acceleration is less than that of decade-old 600 sport bike pistons. With the track-only Speciale version comes an all-titanium Superbike exhaust system that raises power to 226 horsepower at a claimed dry weight of 414 pounds. That is a weight-to-power ratio of 1.83 pounds, HP. To give my 1966 Yamaha L2C that ratio would have required 100 more horsepower than it actually had. They say that bears reach as high as they can on a tree trunk and make deep scratches with their foreclaws, giving notice to smaller bears that this territory is taken. As once observed by actor Robert Mitchum, you can't become tall by taking lessons. But Ducati has pushed its claw marks far up the tree with this V4. That results from 1. Ducati's proven ability to develop reliable high power. 2. Claudio Domenicali's insistence that every Ducati part be the result of weight reduction and performance improvement. 3. Incorporation of what MotoGP can contribute to mainstream motorcycling. For this is a production motorcycle to be ridden every day, not a collector's curiosity to be hung in static ignominy above some hedges fieldstone fireplace. A major goal of V4 engine development was rideability. In general, the greater the valve event overlap in an engine's cam profiles, the fussier and peakier its performance becomes. At the height of racing two-valve sophistication, Manx Norton, Velocity KTT, etc., valve overlaps of 90 to 100 degrees were commonplace. The other end of the spectrum is Harley-Davidson, whose big twins have the valve overlaps near zero. Close on its heels is Ducati's Diavel Power Cruiser with just 11 degrees overlap. At the other current extreme is Suzuki's GSX or 1000, with something like 70 degrees of overlap. Where does Ducati's V4 fall in this spectrum? 26 degrees. That means good strong torque and drivability. A look at the actual curve shows peak torque maintained from 9,000 to 11,500 revolutions per minute with plenty below. That's drivability. Contributing to this is a two-position, variable length intake system. Intuitively we expect variable length intake to be a kind of slide trombone affair, but there's no room and no need. If correct intake length is 7/2 inches at 10,000 revolutions per minute, then we'd need 15 inches at 5,000 revolutions per minute. Where would we put all that 52 mm tubing? Intake systems have already commandeered most of what used to be the fuel tank. So I have a system that varies length by just an inch. Intake length is chosen so it is a positive pressure wave that arrives at the port as the valves are closing. That can boost torque by as much as 10%, well worth having. But what happens at some lower RPM, when it's a negative wave that arrives at valve closure? You guessed correctly, it kills torque to the tune of 10%, creating a weak place in the torque curve. The Ducati system dances around that weak place, avoiding the negative wave peak by going long, short as the engine pulls across its range of highest torque. The two biggest generators of torque are intake flow, the gross amount of charge trapped in the cylinder, and compression ratio, which determines how much push the combustion of that charge gives. A third partner is combustion itself, its speed, completeness, and margin of safety against detonation. The number for this engine is 14:1. Here, Ducati's long development of ever-changing V-twin Superbike engines and 15 years in MotoGP have given it a combustion model that works superbly. While the Japanese companies flailed about in the late 1980s and early to mid-90s trying to learn how to burn big-bore short-stroke combustion chambers, Ducati moved with assurance that really impressed me. Now for weight control, there are other machines with close to 200 horsepower, but they are really power stations on wheels, 500-pounders on long, slow-turning wheelbases. They have their place. Weight becomes doubly important when parts rotate, clutch, crankshaft, wheels, as well as passively move with the vehicle. In the past, the engine and wheels rotated in the same direction so that there are several resistances to direction changing added. But because the V4's engine rotates opposite to the wheels, its resistance is subtracted from theirs, making this bike much easier to flick right and left. Reverse engine rotation is now universal in MotoGP. In this V4 it is achieved by placing an idler gear between the crankshaft pinion and clutch gear. The goal of the Panigale V4 was to be a usable normal motorcycle of tremendous performance. To make it light, every part had to be considered. To this end, the chassis is just two separate elements totaling 20 pounds. The 9-pound forward frame's job is to support the steering head from 4 points on the engine, such that braking and twisting forces are strongly resisted while giving enough lateral flexibility to keep the front tire following pavement irregularities, even at high lean angles when the normal suspension is pointed the wrong way. To achieve this, the four legs of the forward frame had to be symmetrical. But where one of the legs had to go, there was nothing to which to attach it. So, in Panigale V-twin fashion, a three-legged bracket was bolted in place to provide the necessary anchorage. The rear frame is just the 11-pound single-sided swing arm, conceptually consisting of two elements. The first is the very stiff box section arm itself, and the other is its forward section, whose job is to provide lateral flexibility just as the forward frame does. In this case, it is implemented as a pair of vertical blades joining the arm to its pivots on the back of the gearbox. The engine itself is always the heaviest element, but through modern casting, detailed design, and liberal application of magnesium, that package weighs 142 pounds, just 2 pounds more than the engine of Yamaha's 9-time Daytona-winning TZ752-stroke. These solutions deliver MotoGP flexibility, save weight, and please the many Ducati owners who love the single-sided swing arm.